Simply differentiation means it is measuring rate of change, that's all. Okay, how much it has been changed from point to point. That includes whatever you said before, graph 2 points, this and that. Now the derived function, you know that there is a finite value. See this limit x tends to a, f of x minus f of a divided by x minus a is a finite value. This will exist, right? This value, let me take it as f dash of x. Okay, this is a function which is derived from f of x. So this one over here is called derived function. Okay, and the derived function which is derived from f of x with respect to x. With respect to means what? X is main variable here. Okay. Likewise, there is a formula called first principle. Guess what the first principle will be? Finding see, this derived function is called as derivative, right? The process of finding the derivative is called as differentiation. Process of finding the derivative is called as differentiation. How do we find? Initially, by using this method called first principle, that is f dash of x equals limit h tends to 0 f of x plus h minus f of x divided by h. Whatever function is given, if you apply in this, you will get the derivative of the function. Okay, this is one method of finding derivative. And how to denote the derivative? You see, f dash of x, like I mentioned, or dy by dx you may mention, or else capital dy you may mention, and d by dx of f of x. And sometimes it is y dash like we mentioned, or else y1 like we mentioned, and df by dx. Whatever we mention, that means it is derivative of that particular function. Okay. Yeah. Now take one example. Two x plus 5 is differentiable at x is equals 1. How do we say this function is differentiable at x is equals 1? Using the first principle. What does this first principle says? First principle also you can use, or else using the definition also you can use. This is very simple function, better we go with the definition itself. First we need to identify what is f of x. What is f of x? 2x plus 5 function. Okay. At the point A, like we wrote here. Here this x approaches where? 1. So substitute this in that formula. Limit x tends to 1. A means 1. Which point it approaches? F of x is 2x plus 5. minus f of a. F of a means what? Right. F of a na f of 1, which means in this you have to substitute 1. When you substitute, what you will get? 7 divided by x minus a. X minus a is how much? 1. Okay. Clear? Then limit x tends to 1. This 2x minus 5, sorry, plus 5 minus 2 is how much? 2x minus 2 by x minus 1. Shall we apply the limit here directly? No, we can't. 2 we can take out as common. X minus 1 by x minus 1. These two will get cancelled. Then here no x, where we can apply 1. Limit x tends to 1. 2 means it is 2 only. Whether this value is finite or not. Is finite, right? This exists and it is finite. So we can say that this function is to finite value or not, man. Not finite means like this it will come. This is finite value then, 2 is finite value, right? See, that is finite value. So what we can say, if this limit exists and it is finite, then we can say this function, the given function is differentiable at this f of x, given f of x na 2x plus 5 is differentiable at x is equals 1. That is all. Okay. Any doubts on this? Also, you may notice that this itself is a question in limits and derivatives. Remember, limits like we studied one topic. Remember, in that this was our question. Now look at here. Now this is what? A step. Got it? Any doubts in this?